Welcome to the session. We have a treat for you today. There is a ton that's happening in this industry, and Google Cloud is in the forefront in a lot of these cases. And we're going to talk about some of the new announcements and new innovations that we've introduced this year. And so we're going to walk you through that. And then Scott's going to come up and talk about how that's being used for some of the bleeding edge use case for his amazing startup. So before I get into all the innovations that we talk about, and we'll get geeky about the technical things, I do want to just step back and kind of put everything in perspective. We are here to empower you to reinvent your business with AI. Now, there is a lot of theory, a lot of talks here in this session. This session is about how do you actually put it into practice? How do you actually make it real? And the question is, why Google Cloud? There are a lot of other vendors that may promise to do this for you. And we think that we have a pretty unique position because Google has a history of reinventing the future. And you may know some of these technologies, but each one of these that I picked out have spun off multi-billion-dollar, maybe hundreds of billion dollars worth of market just within these inventions alone. So you think about MapReduce. A long time ago, it's a paper that we published, probably unknowingly that it's going to spun off this big market that ended up really driving this notion of big data. And a lot of companies like Cloudera and others have come out of that. That's just one example of multi-billion-dollar business enterprises and industries that come out of inventions that are from Google. Kubernetes. If you may not have known, Kubernetes was actually a contribution from Google to the industry, and that spun off this entire industry of orchestrating your clusters in an easy, resilient way. TensorFlow. Before PyTorch, there was TensorFlow. You may not know that now. It's been a little while. But TensorFlow was, I would say, the first framework to bring ML to the masses. Before that, there was no tool. And we've been working at Google on AI for over a decade now, and TensorFlow was the tool that we used. I'll talk about the new tool that we're using today. But suffice to say, TensorFlow really brought the promises of ML to a wide range of developers. And lastly, attention is all you need paper. MapReduce is also a paper that we published, and that spun off a big industry. Attention is all you need is a paper that was published to introduce the notion of transformers to the world. And as you may know, Transformers is the core engine behind everything that you're seeing today with large language models, MOEs, and others. Right? So really important to just note that because it is in our DNA. And what we do is we work on this ourselves, we consume it ourselves, we bring products to market so that we can provide amazing services like Google Maps and Mail and others to our consumers. But the really important thing is that enterprises then get to leverage all the inventions that we have built so that you can build your own AI agents or AI technologies on top of these technologies that we bring to bear. There are some amazing companies on this list. Technology innovation, those who are on the forefront of building foundation models, Anthropic, Cohere, Augment is a company that you'll hear from on the bleeding edge of developers, developing AI for developers. And you look across and you see that they're solving real problems. For example, Wendy's is using Google Cloud to improve the drive-through experience, right? So the next time you go through the drive-through at Wendy's, just if you happen to remember that the Google Cloud is behind that experience, hopefully you have a good experience there. There's so many amazing examples. Some of the banks in financial services are using Google Cloud and the technologies that we just talked about to improve their chatbot experience and customer services. Right. So let's really get down to the pavement on what's really going on. What are you guys facing in terms of challenges? We talk to customers all the time, and if I were to boil down the set of challenges that you and I typically talk about, it's typically these four things. First is that GPUs are hard to get, right? And this is literally the first thing that comes up when I talk to them is, hey, how can I get access to your latest GPU? And I'm going to talk about that, and I'm going to talk about how we solve that problem. Number two is usability. Doing AI infrastructure is hard. You may need to hire really well-paid PhDs to do infrastructure for you. And we think that we can help with that as well. Number three is ROI. Now, this is one of the things that we talk about with customers all the time. GPU infrastructure is not cheap. It obviously provides amazing returns, but it is not light in your budget. And so how can Google Cloud help? Because this is a major problem. And lastly, Blackwells. We talk about Blackwells a lot. And the question I get all the time is, how do I get access to Blackwells? And then I have a really good news for you there as well. Okay, so I'm going to talk about these four challenges. And the way that we solve these challenges is what we call the AI hypercomputer. Okay, and now you may not know how I went from the last slide to this slide, but I'm going to walk you through how, in practical terms, the AI hypercomputer solves all those four problems for you. Really, the architecture is an integrated platform to give you an experience that is performant, cost-effective, reliable, and secure. So that's what we built. And really, in that, there is three key buckets. First is the way you consume. This is going to solve that first problem that I just talked about. How do I get access? And I'll get into that in I think the one of the last slides. Software is the second bucket. We are doing a ton of innovation on software, and I will talk about how this particular area is solving the ROI and the productivity challenges that our customers face. And lastly, the performance optimized hardware. Let me start with the performance optimized hardware and talk to you about some of the things that we just announced. Before I go there, really the takeaway for you is that we have a really broad range of GPUs that you can get access to today. You may be aware of the A100s if you've been around for a couple of years. H100s, H200s are all available. And I'll talk about some of the other GPUs that in the Blackwell family. And lastly, actually, the L4 GPU is not something that may not be talked a lot about publicly because it is an older generation. But I would say for those of you who are just getting started, it is broadly available all over the world in mass. And it is one of those GPUs that is a workhorse for cost-effective AI serving and as well as training. So what do we announce? There are two products that we announced and one product that we announced just a month ago. Let me walk you through it. The H200 GPU was announced just a couple of months ago. It is the best perf per dollar for your current gen workloads. It is available now. It is available for you. It is something that you can get access to today. And the amazing thing about the H200 is that it delivers tremendous performance for what you've probably been hearing through your years about this test time serving. So I don't have a slide on this, but I'll just tell you verbally that on the latest DeepSeek model, the largest DeepSeek model, you'll need about 16 H100s to host that one model. With H200s, you need 8. So just half the number of GPUs to serve the latest foundation model. That's really the value prop of the H200 GPU. It is equipped with the latest GPU to GPU networking with RDMA. Now, for some of you, this may be something that is kind of a snooze because it's always been there, but for Google Cloud, it is new that we are introducing RDMA over Ethernet using NVIDIA's technologies on the networking side to give you the best performance for training and for large-scale serving. We're also very excited to announce that B200, the first Blackwell GPU, is now available. It was an announcement that came out last night. We're seeing amazing performance out of that GPU. And on training, we're seeing over 2x the performance of Hoppers at scale. We're likely the only cloud vendor that actually has B200s at scale. And so we were able to test this at over 1,000 GPUs, and it's sustaining over 2x the performance against H100s for some of your typical large-scale training workloads. What we're truly excited, though, is about serving. On this slide, you are seeing 1.5 to 3x inferencing serving versus H100. In the latest testing that we've done, we're seeing almost up to 3x serving throughput versus Hopper. Now, I don't work for NVIDIA, but I do have to say that is an amazing feat just to go from one generation to the next and to deliver almost up to 3x the throughput from one generation to the next. And the way that is done is through the use of FP4. And so you may not even need to know that it's done with floating point 4 bits because that is all integrated for you in PyTorch and other frameworks. But the fact of the matter is, if you're using these models that are open source or industry standard, you will likely get that benefit right out of the box and will get amazing performance. And that's available now. Every time I talk to customers, they're surprised that Blackwell's actually here. Even though we talk about it, and it is here now. It is generally available, and you could stop any of the Googlers here and ask for how to get access to them. And lastly, we announced that GB200 is coming soon. It's in preview now, and we're super excited about it. We've done some initial benchmarking. It looks amazing. All of this is built on, again, I'm going to highlight some of the Google technologies and inventions. The blue box down under called Titanium ML. Basically, it's our technology to deliver all of this in a secure, virtualized way so that you don't have to worry about your data being compromised in any way. So, what does this look like in real benchmarks? A3 Ultra is, again, I mentioned, is H200. It shares the same fabric technology as the B200 or the A4. So the scaling characteristics should remain the same. The amazing thing about this, if you look at it, is on the bottom, this is a number of GPUs. Right, and of course this is just tokens per second or throughput. Ideal scaling is in the orange bar, and you're seeing that with the systems and the offering that we have, you're essentially getting the best perfect performance no matter what scale you need to run your workloads at. All of this is done with another Google technology called JAX. I'm going to just do a quick poll. How many of you heard of JAX? Just by the way. Okay, we have some work to do. I'll bet half of you guys are Googlers. Okay, so JAX is an alternative to PyTorch, and PyTorch is amazing. We support PyTorch all the way. JAX is what we use internally. DeepMind uses it, and it is what we use to train Gemini. And it simplifies your large-scale training significantly, and also delivers this ideal scaling. So if you were to kind of put this side by side with other frameworks like PyTorch, JAX just out of the box in a simple way delivers this kind of training scaling. And so again, we support everything, but this is what we use internally to drive our innovation. Okay, so I talked about our hardware. Let me just switch over and talk about some of the problems that, the core problems that you guys face about productivity, and we solve that with open software. Let me just pin this with a problem statement. And if you are doing any training at all, this graph, even though it looks complex, in a split second would make sense to you. What this graph is showing is a typical training scenario where the blue line at the bottom is when you finish your training job. And you would want it to look like this. Over time, just in a linear way, as time goes, you just finish your job without any hiccup. The reality is your experience looks more like this. Okay? And there could be things like, well, you need to just kind of iterate to make sure that your model is mapped well to your infrastructure. You may need a checkpoint, save your checkpoint, which is a little bit of a slowdown here. You might have job interruption for whatever reason. If you have thousands of GPUs, you're bound to fail at some point. A GPU may fail at some point, and so you need to do a checkpoint restore. You may need to pause your job for a little bit as you figure out what the failure is in the fabric. And the reality is that the customer experience looks a lot more like this. Within Google, we figured out how to make that jagged line look more like a straight line. And not a straight line verbatim in that way, but more like it. And we are going to introduce some of these technologies over time, but I want to share with you one thing that we are starting to talk about. So let me just kind of set that up with what is the process in which you get to that more straight line? And for those of you that are doing training, you are familiar with this process. You deploy your model, and there is kind of 3 stages as you think about your productivity. There is checkpointing, your monitoring, and your doing remediation in terms of when there's failures. And the service that we are giving to our customers and to those who are working with us is called Elastic Training. So let me kind of walk you through this. When there is a GPU failure, and this is a GPU in red, and you've kind of mapped your parallel strategy along pipeline parallel and data parallel in this way, there's several ways that we can recover your job really, really fast. And the service will do this in an automatic way for you. First, if there is a correctable error, the service there is actually, I didn't talk about this, really ultra performant checkpointing service that's undergirding this technology so that it will restore from local checkpoint from the system RAM, from the fastest storage device, to restart your job automatically for you. If it's an uncorrectable error, then it will automatically hot swap that system or that GPU for you. Okay? Or if there is no GPU to spare, then this technology will work with you automatically to remap your parallel workloads to keep going until a system is ready for you to then restore that parallel work. So I know that's at a high level. I didn't go into a lot of details, and if you're interested, you could stop by afterwards and and ask me questions, and I can get into details of it. But essentially, this is just one of many ways in which internally we've figured out a way to keep your job 100% productive. And we want to share that with the rest of the industry. Just the anecdote, we actually just launched this internally to try it out on GPUs. And our, what we call good put, the amount of time within your training time where your job is actually productive versus not, without this technology was about 85% productive. With it was 97% productive. Right, so really a game-changing technology that is from Google. Okay, so let me just wrap this up and bring Scott on board. Let me just quickly talk about the last bit, the last bucket, which is flexible consumption. Now, this solves one of the most frequently asked question, which is, hey, how do I get access to GPUs? You guys are always stocked out, though we're not. And or it feels like it. And so can I get access to GPUs? And the answer is yes. In fact, some of the largest enterprises have used this new tool that we introduced last year to get access to any kind of GPU that you want. We call it Dynamic Workload Scheduler. And the way that it works is there's two modes. One is Flex Start mode. In that scenario, you actually queue up your job and we will run that job for you when the resources are ready. So we have pools of GPUs that are completely dedicated to Dynamic Workload Scheduler. No other customers that is not using what we call DWS is using that pool. And in that pool, we'll queue up your job. And if your job is okay to use that kind of approach, we will run that job when the GPUs are ready and we'll give you the results back. Okay? The second mode is called calendar mode. And this is really cool. It's essentially, you tell us when you want to run your job and for how long. So you tell us, hey, March 31st, 12 a.m., I want to run for 7.5 days. And we will go ahead and schedule your job for you. And once we confirm that it's scheduled, it is 100% guaranteed. Okay, so, and it sounds magical, but it's really turned a lot of the businesses and our customers around in terms of their access to the latest GPUs. So DWS is available for all the Hopper GPUs. It's available for the new Blackwell GPU. And if you're interested in getting access to Blackwells, this is the way to do it. Okay. All right, and just to show that this is real, a customer, Two Sigma, has made use of DWS, actually built the workflow around DWS, and increased their obtainability by 80% using this tool. All right, so I went through that really quickly, but I do want to bring Scott up and talk about how this actually, Google Cloud and all the products that we offer actually gets done in the real world by one of the leading companies in the world in this space and in developer tools. And so let's bring Scott up now.
Thanks, Roy. Pleasure to be with you all today. So we launched a service on GCP, about a year ago. And I'm going to tell you a little bit about how it works and how we're taking advantage of GCP underneath. So really quickly, most of the AI tools for software development kind of target the vibe coding 0 to 1. We're going the other end of the spectrum, right? So we try to look after tens of millions of line, complex repos, bring AI to bear in true software engineering. That's why we joke that it's about doing real work. Lots of enterprise customers around using the technology. I can actually show you a little bit of it in action here in a moment. We keep real-time synchronization with your code base. Oh, that's why.
Oh, there you go.
Hallelujah. So even as your code changes, the AI is always up to date and current. We work with off-the-shelf IDEs, so you don't have to worry about forks and incompatibility with vendors' ecosystems. You don't have to worry about picking models or trial and error because we do the QA for all the different models that we use in the solution. So here's just a really high-level picture of how we're built on top of GCP. So our engineers tend to be not easily satisfied. I'm sure many of you can identify with that. I struggle to get them to find things to complain about on GCP. Literally, when we have an issue, more than 99% of the time, the issue is ours. It's not in Google, and it's not in the underlying NVIDIA architecture that we're using. And that's the strongest testimony that I can give to the platform. We make use of a bunch of Google services. In addition to JKE, Kubernetes Engine, we're using Bigtable for customer data. We're using BigQuery for analytics, billing. We use PubSub for being able to index these large code bases. I love the fact that we can mix and match our training and our inference. So we can dial up inference as we have new customers coming on the platform, but off hours of the day, we can use and make big training runs. And so that's a huge benefit of GCP and the underlying NVIDIA architecture that we can take advantage of that. We've been able to get H100s as well as B200s when we need them. We're seeing about a 3x performance between the two on our workload, which is outstanding since the price increase is not 3x. So I think it's a win to take advantage of. And then this is just a really quick look at how we're using NVIDIA underneath. So I do like the freedom that it potentially gives us to be able to support multiple clouds, but the fact that we get great performance for a blend of training and inference and we can move things back and forth is hugely valuable to us. We're at order 1,000 GPUs right now, but planning to scale ideally this year into at least 5,000-6,000 kind of GPU workloads. We have really deep CUDA expertise on the team too, and that's one of the big benefits for us with NVIDIA is that we can go into the stack. So we have a highly customized inference engine that we use. We do a bunch of model training, so we start with open source models of all kinds of different sizes. We do a bunch of post-training on this infrastructure ourselves, although we also take advantage of frontier models and doing so through the GCP infrastructure to take advantage of that. So just for fun, this is VS Code that I have opened up. Augment has a standard plugin that's running inside it. The first thing Augment will do is look at the repository. I've actually opened up Augment's own code base here. So Augment will, because we understand big complex code bases, actually take a look at it and summarize what this code base is about. And I could have a chat conversation and dig in and understand more, but it's a little more fun to turn on something new, which is Augment's agent. This is not yet announced, but just shipping to customers. Wait, sorry, I have to pick up my linear ticket. I could type in the request, but I think it's more fun to show the integration off. So on the back end, Augment will go talk to Linear, pull the ticket out, and it's going to do an analysis of what this ticket requests it's asking for. So we have an edit data structure that we want to potentially, or that it gets exported, and we want to add a session ID to it. If you don't know anything about the code base, you might get this kind of request when you show up at a new engineering operation. You can just ask an Augment agent to read this request and come up with a plan. So it's actually going through right now and generating that plan to implement it. But I'm going to hop back in the presentation and just share a couple more thoughts, and then we'll come back to it. So there's a lot of hype about agents. One of the things that GCP is going to like is agents take a significant amount of computational cost to think about what they're doing. They're much more autonomous than the development capabilities that have been delivered to date. But there's also a substantial amount of hype around agents. And I just want to kind of set the playing field about what you're going to get. People like this concept, right? Every developer becomes a tech lead and they can send a dozen agents off to do various pieces of work. The reality is if agents don't understand your code base, they won't be successful. The more autonomous, the higher level work that you want to give to an agent, the more critical it is that it understands your code base. So the demos make agents look magic. The reality is the vast majority of the work programmers do isn't 0 to 1. It's about taking some existing complex code base and modifying it. There are no simple changes inside of a scaled system like Augment. People position agents as being able to do everything, take over large tasks. Reality is they need a lot of guidance from engineers, and think to break up a broader problem into smaller steps, you'll have greater success. And lastly, they're not going to replace human software engineers anytime soon. The vast majority of what programmers do is think hard about things like, what are the goals for my migration? What tech debt do I have? Where are the performance optimization opportunities? Security vulnerabilities? How do I better harden this architecture? These goals, these aspirations for software are very much still the domain of humans, and how we're going to go about achieving them requires human insight. So it's the combination of human and machine that is going to work better. Our conviction is there are going to be more software engineers in 2 years than there are today. These tools do require integration with other things in the stack. We're taking advantage of the MCP, Model Context Protocol, to do that, but then we have custom integrations for things like you were just seeing. And these agents can be uniquely trusted, but I don't want to get too deep on that. Here's one fun, this is also not yet announced. We just had the high watermark on SWE-bench for agent performance on GCP and on NVIDIA. Thank you for that platform. And let's go back and just check. And so what you can see is Augment is going through looking at the code base to understand the request. That's the context engine that is finding things. It's found the right class. It's looked at what needs to change in terms of adding the session ID, and then thought about how to pull it through the whole rest of the code base. Deserialize, serialize as it's written to and from a database, changing APIs, changing scripts, all of that taken care of. All I have to do is say yes, and it will wrap all of that work up. Okay, that was the quick whirlwind tour. I think Roy and I are going to take questions. Hopefully you guys have some.
So I'm curious. So because the ecosystem for startups right now is the overall setup. Let's say you want to do. Everybody wants to start their own setup now, autonomously AI compliant, with as less employees as possible. So with this, you're saying, okay, this is so much more effective, and the error rate is much lower, and your engineers approve of it. Oh, hi, thank you. And so I'm just curious, what are the? Let's just make it simple. The top 5 and you can promote Google, that's fine. The top 5 basic foundational software processes that will work well together, but also, because when you project into the future, 5 years, 10 years, some companies may disappear or go away. And so, migration sucks. Nobody wants to migrate, especially from humans, actual employees, to automated. So, and from software to software. So what would you, I'm just curious your recommendation of just right now, presently, because I know tomorrow the answer will be different.
So I obviously concur that you want to have as much portability as you can in your code base. I think you use mainstream programming languages. We use a lot of open source infrastructure. Obviously things like Kubernetes is open source, but we're using GKE underneath our platform. The Bigtable, BigQuery, they're extremely reliable, extremely scalable. I mean, this is so powerful because we've gone from thousands of users to tens of thousands of users, literally over the course of a month. And that kind of explosive growth is not easy to accommodate if your underpinnings aren't capable of that sort of scale. And so, if you want to shoot for the moon, and the crazy thing is the kind of growth that you can drive in these AI businesses, we've never seen it before. And so I highly recommend choosing infrastructure that will not hold you back in terms of allowing you to scale. And if you take a portability hit that's modest for that upside, it's a no-brainer.
The benchmark looked pretty cool. Did you also compare with the thinking models or like chain of thought models? I thought I only saw 3.7 Sonnet, but I'm assuming that wasn't the thinking
Sorry,
model.
a little louder.
The benchmark that you showed about the Augment's like in-house coding model, how does it stack with like the chain of thought models? It seemed like I only saw the non-thinking model there.
So that score is the highest that I'm aware that an agent has achieved so far. But one would expect that this competition is going to continue to heat up as agents go. There's a variety of different models being used underneath in our solution. And then we're also able to bring knowledge from the code base to bear. That's one of the things we do that allows us to do better than the other tools in the marketplace. So I would, have fun watching these benchmarks because we're all going to race to see who can do the best job.